All right, guys, one more really quick video here of graphing rational function. We worked on this in class today, and I'm going to show you one more example. Make sure you're good, and we'll work on it some more tomorrow. It's one of these lessons where we really need a couple of days so you can see everything. So here we go. It says y equals x squared minus 2x minus 3 over x minus 4. First thing you always do when you can, obviously, is you factor your numerator and denominator. That's going to be x minus 3 over times x plus 1 over x minus 4. So now let's start our stuff here. Our vertical, got to come up with that. A horizontal, maybe. A slant, maybe. X-intercept, maybe. Y-intercept, maybe. And then we'll add domain and range also. Okay, so vertical is whatever makes the bottom 0, remember? X equals 4. Horizontal, this time the top degree is bigger than the bottom degree, so that means there's no horizontal. Because the top degree is 1 more, there is a slant. I'm just going to put yes, there is a slant. The x-intercept is whatever makes the numerator 0. There are 2 of them, 3 and -1. The y-intercept, remember, we're going to cover up the x's. So if I cover up the x's, that just leaves a -3 and a -4, which is positive 3/4. And I'm going to save the domain and range for after I fix my graph. So let's graph this thing. My vertical asymptote is at positive 4, which is there. The x-intercept is at 3 and also at -1. The y-intercept is at 3/4, which is about right there. And all I'm going to do now is I'm going to punch in my calculator and see what it tells me. All right, I'm going to be honest here. I had to extend my x and y axis to see both of them. The first thing that showed up on my calculator was this curve, looking like that. The second one, once I zoomed out a little bit, or you can change your x and y, max them in on your window, it's going to look like that. All right, so there's a slant asymptote. You can kind of, I didn't do a very good job there, but you can see the slant should be going somewhere through there, but it should have a slant asymptote. Now the domain, x is going from -infinity until it gets to the vertical. And then it goes from the vertical to forever. And I'm going to be honest with you here with the range. We are not going to do range when we have a slant asymptote. Okay, if we had a horizontal one instead, I would do the range. But there's a gap in here between the two graphs, the two parts of the graph, and it's hard to know how big that graph is, or how big the gap is, or where it starts and where it stops. So we won't worry about doing the range on the slant asymptote yet. Okay, so that's all we got. See you tomorrow.